The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello, good evening everyone. Am I audible? Hello, good evening everyone. Am I audible? Yes. So what were we discussing in the last class, everyone? What were we discussing in the last class, everyone? Yes. So what we did yesterday was, okay, yesterday we understood what you mean by microcontroller. Then we understood what is the difference between microcontroller and microprocessor, correct? Then after that, what I told you, what you mean by host, what you mean by laptop, what you mean by cross compiler. So in our case, which is our host? In our case, which is our host? In our case, what is the host? Yeah, laptop is our host. In our case, laptop is the host. Okay. Okay, what is our target? Which is our target? Which is our target? Which is our target, everyone? The microcontroller board, which is nothing but PIC Genius. PIC Genius board. Okay, in our case, the target is the PIC Genius board, microcontroller board. Okay, whose name is PIC Genius. Okay, I showed you yesterday in the PIC Sim Lab simulator. The board we are using is PIC Genius, and the controller is nothing but PIC 16F877A. PIC Genius is the target from PIC Simulator. Then our controller, what we are using in this module is PIC 16F877A. Okay. Later, what we saw, what we planned was, okay. We planned, okay, we will write our first code after knowing these all things. I showed you what you mean by cross compiler, what is a native compiler, and we are supposed to use the XC8 across compiler. Okay. Next, what we are having here is, okay, the microcontroller, okay, and the ports. So actually what we planned is we will start writing our first code, and we decided that our first code should be simple. And when we saw the board, what all our board contains means there is a controller, there is a CLCD, SSD, switches are there, sensors are there, relays are there. I showed you the board architecture. I showed you the board architecture. In that, which is simple means simple is LED. So we will write our first code is simple code. Okay, then I opened a board and we saw that there are totally 16 LEDs. There are totally what? 16 LEDs. Now, if I have to program this LED, what I have to know is I have to know to which port LEDs are connected. Okay, what do you mean by port? Port is nothing but okay, a interface through which okay, external peripheral can be connected to your microcontroller through which okay, it act like a bridge okay, to which your external peripheral can be connected to a microcontroller. Then what we did was we opened the data sheet of the microcontroller. From there, we understood that there are totally 5 ports A, B, C, D, E. There are totally how many ports? 5 ports are there. A, B, C, D. 5 ports are there. Okay, that we understood from the data sheet. Data sheet is nothing but it talks about all the details of your controller. So let me repeat one more time, which is the controller we are using. PIC 16, PIC 16 F877A is the controller we are using. And that controller is having 5 IO ports. IO means input and output port, where you can connect input peripheral or output peripheral. Okay, and later one more document we opened, that is schematic. From the schematic we understood that our 16 LEDs, in that 8 LEDs are connected to port D, next 8 LEDs are connected to port B. This much we understood in yesterday's class. Correct? Till here correct? Till here we have covered in the last class. What is schematic? It is a blueprint of your board. It will tell your board contains what? MUSI stands for microcontroller. Microcontroller short form is MUSI. Microcontroller. Okay. Then what we did was schematic. What is schematic? Schematic talks about the board. Okay. Schematic talks about what? Board. Okay. Okay. MUSI means nothing but microcontroller. Schematic is nothing but it talks about the board. Your board contains what all peripherals and where they are connected. What all peripherals and where they are connected. Now coming to the schematic. Okay, we got to know that 8 LEDs are connected to port D, 8 LEDs are connected to port B. I showed you in the last class. Do you have any questions, any queries till now? Schematic. Okay, it's not there in the LMS. Schematic is not there in the LMS. Okay, 1 minute. I will share the schematic. If it is not there, I'll just put it here. You download it from here. Yeah, I'm uploading it. You can get it from there. Yeah, you can just go and get it from the, okay, go to me in the meeting app. Mitra, I'll show you. Okay, how to use the board in the simulator, I'll show you. Yeah, till here things are clear. About the tools, how to use, I'll tell you. Did you complete the installation? Okay, please do complete the installation. You can find it in the materials. Okay, that file you can find it in the materials. You can install anywhere. You can do it on Windows or Ubuntu. Mac is not supported. The three tools you have to install. Okay, Mac is not supported. Please do it in either Windows or okay Ubuntu. No Mac. Karthik, it is there in the material. You can get it. Schematic is there in the material. Here only I have shared in the GoToMeeting app. There in the material it is there. You can go and get it. In the material it is there. Okay, fine. Now we'll proceed further. You can install any version. Anything is fine. You can install any version. Okay. About more about installation, you can post your queries in the discussion forum. Let us proceed further now. Okay, so we got to know that LEDs are connected to port D. So what we will do is we will try to write a program for LED. Before writing about the program about LED, we have to know about the port D. Okay. So again, what I will do is I'll open the data sheet. We will open the data sheet of our controller. That is PIC16F877A. 1 minute, I'll okay. So you have the data sheet. Please open the data sheet in the material. Okay, you are having here in the data sheet folder. In the data sheet folder, you have this PIC16F877A. Open that document. Open the document from your datasheet folder, PIC16F877A. See, you might have downloaded it through okay LMS. Okay, here in the internship, okay, you are having C programming resources. Class recordings are there. After that, microcontroller resources. Here you are having board schematic, template code, slides for installation. Okay, yeah, so please complete. Here it is there. Okay, template. Here you are having the okay uh, schematic and the data sheet. Download from here. Data sheets and the schematic is here. Download it from here. And also I have started one poll to check about your installation. Please answer this poll by tomorrow. Okay, answer this poll whether your installation completed or not. Answer this poll before tomorrow's class. Okay, in the LMS, I have started a poll. Please complete your installation and answer the poll. Okay, by tomorrow's class begin. And you can download your material from here. Okay, all the study materials are here for microcontroller. And someone is asking about classes. Classes are uploaded here. The classes links are uploaded here. Fine, we'll proceed further. So if you open the document, the datasheet document, now we open this datasheet to understand about port D. Okay, so here I have IO ports. In the IO ports, port D we are trying to understand. This is port B, port C. Okay. Yeah, we'll start with port B only, that is coming first. Port B. Since LEDs are connected to port B, we understand port B here. Yeah. Can you read this for 1 minute? I'll give you time. Read this. Let me repeat one more time. We have 16 LEDs on our board and our intention is to program these LEDs. And from the schematic, we understood that our 16 LEDs are connected to port B and port D. If I have to program this, okay, LEDs, I have to know about this port B. So for that, I am opening the data sheet and studying port B. Please read this. Page number 46, port B. Open page number 46 in the data sheet, port B. If you are not opening also a file, just read it from here. Read this paragraph, everyone. I'll give you 1 minute. Okay, are you done? Everyone, did you done the reading? Hello, everyone. I asked you to read this paragraph. Are you done? Okay, fine. So what this, okay, is telling about this port B. Okay, so what is happening? Port B is a 8-bit wide. It is a resistor. It's a 8-bit wide and it's a bidirectional port. Bidirectional means it is both input and output port. The corresponding data direction resistor is tris B. By setting the tris B bit as 1, will make the corresponding port B as an input pin. Okay, by clearing it will make it as a output pin. Okay, so this is what we are having here. Let me, okay, write it down. So what is this? This is a port B. It's a 8-bit wide. It means it is having eight pins. What are those? RB7, RB6, RB5, 4, 3, 2, 1 and 0. These are the bits belonging to port B or pins belonging to the port B. This we have seen in the last class, correct? I showed you. This is having 8 pins. Now this port B is both, okay, bidirectional. Bidirectional means what? You can connect input peripheral or you can connect output peripheral. Means input means what? You can connect a switch to give a input. Output LED, you to get output. So it is acting like input pin also. These pins will act like input pins also. They can act like output pins also. This port B 8 pins are there. They can act like input pins and output pins. Now, who will decide whether it is input or output? Who will decide whether it is input or output? Tris B is a data direction resistor of port B. It is what? Data direction resistor of port B. It is also 8-bit wide. Okay. It's also 8-bit wide. DDR, data direction register. This will decide whether port B pins are input pins or output pins. Okay, so if I assign tris B 7, 6, 5, 4, 3, 2, 1 and 0. These are the bits belonging to what? Tris B. Tris B 7, 6, 5, 4, 3, 2, 1, 0. This belonging to what? Tris B. Data direction registers. Okay. By assigning tris B will decide whether port B is an input port or an output port. Example, if I assign tris B with 0, 0, 0x, 0, 0. Then what will happen? Whole tris B will act like what? Output port. Output port. If I assign tris B with 0x FF, then whole port B will act like what? Input port. Input port. Tris B is equal to 0, 0, output port. Tris B is equal to FF, input port. It means you are assigning 0, 0 means what? All zeros. 1, 2, 3, 4. 1, 2, 3, 4. If you are assigning this as FF means what? 1, 1, 1, 1, 1, 1. So what you assign to tris B will decide, okay, what port B is acting like. If you are assigning tris B with 0, 0, okay, port B will act like output port. If you assign, okay, FF, then port B will act like input port. Okay, suppose if you assign here tris B with 0x, 0f, then what will happen? Half of the pins will act like output, half of the pins will act like input. Port B, MSB will act like, MSB pins will act like, okay, input. Okay, 1 minute. Yeah, hello. Yeah, if I assign tris B with 0x, 0f, what will happen? Half pins will act. Okay, how many pins? Port B's. Okay, 8 to 4, okay, 8, 7, 6, 8 to 5 pin will act like, okay, output. Instead of 8, sorry, 7 to 5. Output. 7 to 4, then 3 to 0 will act like input. 3 to 0 will act like input, 7 to 4 will act like output. clear about a tris B, port B? Are you clear with these things? What is tris B? What is port B? Data direction resistor. DDR stands for data direction resistor. Everyone, are you clear with this port B, tris B? Yes. Now what we will do is we will try to understand how to write the code now. Okay, what all information we are having? Okay, we are having information that we are going to program 8 LEDs, and these LEDs are connected to a microcontroller. Okay, via, okay, 1 minute. These are connected via what? Port B, and port B is a 8-bit port, and this can be controlled, okay, via, okay, data direction resistor, which is nothing but tris B. Okay, this much information we have now. Okay, now what we are planning to do, we'll write a program to toggle the LED. We'll write a program to toggle the LED. Toggle the LEDs. Okay, let me draw it for you. This is what we know now. This is your microcontroller. Here we have port B. To this port, okay, our LEDs are connected. I showed it in the schematic. Port B. Port B, this is nothing but your microcontroller. This is your port B. Totally we are having how many LEDs? Means 8 LEDs. Okay, this much information is clear, and this port B, it is a input port, output port. To control whether it is acting like an input or output, we will be using a tris B to make this port as input or output. This much information we have now. So by having this information, what we can do is we can try to toggle the LED. We can try to what? Toggle the LED. Fine. So first what we will do in order to toggle the LED, first let us write down the steps. First write down the steps, then we will see how to write the code. Okay, we'll write the first steps. So what do you think, what should be my initial steps if I want to write a program to toggle the LED? What should be my step 1, then 2, then 3, what I should do? Yeah. So what should be my first step? What should be my first step? If I have to toggle the LED, what should be my first step? Toggle LED means what? Turn on the LED, turn off the LED. So my first step should be what? We have to configure the, we have to configure the, whichever port we are using. Okay, configure port D as output. Configure port D as what? Output. Sorry, port B, not port D as output. After that, turn on the LED. Turn on the LED. How to turn on the LED? Just assigning what? Port B with 1. Okay, by assigning 1, 1, 1, 1, all the LEDs will turn on. Okay. Then, after that, immediately I cannot turn off. Immediately I cannot turn off, because if you turn on and turn off immediately, what will happen means, okay, you cannot see it. It is very fast. Human eyes cannot see it. So what we have to do is we have to provide a delay. We have to provide what? Delay. Then turn off the LED. Then turn off the LED. Turn off the LED. Okay, so for that we have to assign port B with what? 0, 0. All the LEDs off. All the LEDs off. Okay. Then we have to repeat. We have to repeat the step. If I want to do it again and again, go to step 2. Go to step 2. port as output, turn on the LED, delay, turn off the LED, then repeat the steps. Yeah, is this clear? The steps, are they clear? These are the steps we have to follow in order to toggle the LED. Are the steps clear? Are you clear? Please do respond. Is it clear? Not clear? Yeah, after turn off also delay is required. After turn off also delay is required. Yeah, after turning off also delay is required. Yeah, fine. Now what we will do, these are the steps. Now what we will do is we will see how to write the code in the MPLAB ID, and these are the steps we have to follow. How to write the code in the MPLAB ID, how to compile it, how to see the output on the simulator. To write code in the MPLAB ID. Write code in MPLAB ID. MPLAB XID, how to create a project, how to write the code, we will understand. After that, how to compile it. After compile it, how to execute this on FixinLab. That we will see. See Shrikant, okay, 111. We are not assigning it to the, okay. See, if you assign TRISB with 111, port B will act like input port. Okay. TRISB is different, port B is different. We are not assigning port B with 111 to make it as input output. To make it as input and output, we'll assign values to TRISB. To turn on and off the LEDs, we'll assign to the port B. See here, we are having two resistors. One is port B, one more is TRISB. TRISB to make it output and input. Port B to make it as on and off. We are using two different resistors, Shrikant, not same resistor. Port B to control LED. TRISB to make port B as output and input. They are two different resistors. Okay, fine. We'll proceed further now. Okay, so as I told, we'll write MPLAB code in the MPLAB XID. Okay, So what we are going to do is we are going to follow one template. What is a template? Means we'll have one function initially init config. In this init config, what we will do means we will write only the initialization part. We'll write only the initialization part. In the main, okay, this is a, we'll be not returning anything from this main, so I'm not passing anything to this main, it will be void only. Because it's the first code that will be running. Void. Okay, then init config. While of 1. Okay, so what we will do here is in the init config we will put the first code, the initialization code, which will run only one time. The initialization code which you want to run one time. One time code here in the init config will put. The code which you want to run repeatedly will put it inside while one. This template will be following to write the code. Yeah, one time code. Okay, that example, configuring port B as output, this is one time only. You need not do again and again. But toggling LED will do again and again. Okay, this is one time code. This we will repeat again and again. Okay, so this should be inside what loop? Okay, fine. Is this clear? So we'll be following this template. So I'll show you how to create the project. So everyone please follow me and do it. Let me tell you, I will not repeat again and again. Okay, please try to do along with me. If you're not able to do it along with me, okay, you watch the recorded session and do it later. Fine? Yeah. So what I will do is now everyone, if you have installed MPLab ID, just click and open it. Click and open it. Open the MPLab ID, it will take certain time. I will be going slow as much as possible. Okay, don't ask me to repeat. If you're doing along with me, good. If you're lagging behind, please watch the recorded session and do it. Okay, I will not repeat any steps. I'll be going as slow as possible. Yeah, fine. So when you open your MPLab ID, it looks like this. It looks like this. Okay, here we have many options. We will see them one by one when required. As of now, what we are supposed to do means we are going to write a new code. That is our first code, LED code. So when you are going to write your first code, right, you have to create a new project. We have to create what? New project. So in order to create new project, go to file, then select new project, go to file, select new project. Okay, when you select a new project, a window will pop up. In that window, select microchip and select standalone. If standalone option is not available, just select microchip is fine. If you are not getting the standalone option, no problem. Just select microchip, that is fine. Just select microchip embedded. Microchip embedded, that much only you select. If standalone option is there, select standalone. Then next. Okay. file, okay, new project, file, new project, a new project, select microchip embedded, standalone, then next. Then controller, pick 16F, okay, 877A. Please select your controller, type it. I'll give you time. So it will ask you to select the device. So select pick 16F877A. Pick 16F877A. Option will get. Pick 16F877A. Okay, selected the device, pick 16F877A. Then next, you are selecting your controller. Here, if you want, select simulator tool, otherwise leave it. It's okay. Leave tool. Then next. Then next. Then select your compiler here. Select a compiler, X8 compiler, any version you can select. Any version you can select. Select your compiler. Select your compiler. Okay, then next. After that, okay, after that, what you have to do is you have to browse, okay, where you want to create the project. Okay, what I will do is I will create the project in desktop only so that it will be easy for you. You also create your project on desktop. Create your project on desktop itself so that it will be easy for you to locate the project. Desktop. Okay, select the path where you want to create a project. See, your project location is coming. Select the path where you want to create your project. Let me create it on desktop. Okay, so once you select your location, then give the name of your project. Since I'm going to program LED or toggle LED, I'll give the name as blink. I'll give the name as what? Blink. You can give LED, you can give anything. I'm going to give the name as blink. Project name, you can give anything. I'm going to give it as blink. So choose your location. See, let me tell you. First, open project. After project, select your microchip embedded. Then select your controller device. Pick 16F877A. After selecting the controller, select the simulator. Then select the compiler. Then give the name of your project. Give the name of your project. Then finish. Then finish. So your project will get created. Okay, let me put the steps here. So when you are creating a new project on your MPLab ID, first go to Files, in Files, New Project. In New Project, a window will open up. In the window, select Microchip Embedded. Okay, Microchip Embedded. Then select your device. Okay, selecting your device is nothing but your PIC controller. Our controller is PIC 16F877A. Then select the tool as a simulator. Okay, after selecting the tool as a simulator, next what you will do is you'll be selecting the compiler, Xe8 compiler. Select it, then choose the location and give the project name. Choose location where you want to create your project and give project name. Okay, whatever I showed you, same things. Okay, do it. So I already created a project. You can see once you create a project, you can see here you'll get these all files along with your project: header file, important file, linker file, source file, library, loadables. Okay, now we are supposed to write one main file. We are supposed to create one main file. So in the source file, you can add your C files. In header file, you can add your header files. Okay, important file by default a make file will be created. Okay, now yeah. So now what you do here is okay. Once you create your project, we are supposed to create a file. First, we will create a template. Okay, what is a template means? Go to here tools. Go to here tools. We'll create a one template. Okay, main template will create. Go to tools. Go to templates. Go to templates. Tools. Then templates. In the template, okay, microchip embedded. Microchip embedded. In microchip embedded, Xe8 compiler. Xe8 compiler. Then main. Okay, then main. Let me repeat one more time. Tools, templates. Tools, templates. Then microchip embedded. Then Xe8 compiler. Then Xe8 compiler. Then main. Select the main. Select the main.c. Open in editor. Main.c. Open in editor. Yeah, you will be not having these all things. Please type it down. I'll tell you why. Yeah, this Xe8 compiler. Okay, we will be using this port B. Okay, port D. Trace. Okay, B. These all. Okay, variables are there, right? They are predefined inside this xe.h. So we have to use this header file. These are predefined there. They are predefined. At the address, at the particular address, they are predefined. Okay. Then here, okay, next thing is we are turning off the watchdog timer. Turn off watchdog timer. This will reset the board again and again. So what will happen if you don't do this? It will reset the board. Okay, what is this watchdog timer? I'll tell you later. As of now, just do it. Turn off watchdog timer. Please type this down in your template code. Type this down in your template. After typing down, just save it and close it. Save it and close it. Just we are creating a template. We are just creating what? Template. Just create a template. Okay, are you done with typing this code? Done with typing this code in your template? Are you done typing this? Done typing this? If yes, good. If you know, you do it watching recorded session, okay? Fine. So I'll just, okay, save it, control save it and close it. Just close it. Okay. Just close it. Yeah, we have created a project. Now what we are supposed to do means, okay, we are supposed to write the code. So for writing the code, we have to create a main.c. So right click on the source file, right click on the source file, new main.c. Let me repeat one more time. We have created a project. In the project, we have to write a code. We have to write a code in the main.c. So we have to create a main.c. So all .c files will be under this folder, source files. So just right click on the source file, new and main.c. Source file, new and main.c. Okay, in the main.c, let us have main. Then finish. Yes, created. Yeah. So let me repeat one more time. What is this xe.h means? This is a header file. You have stdio.h in C, like that xe.h in okay microcontroller, where these all things are there. Port D, address B, these all variables are defined there. Okay. Then watchdog timer we are turning off. What is watchdog timer? I'll tell you later. Don't worry. I'll show you what will happen if you don't turn it off. Okay. Then we are having our template. In the init config, we have to write the code which you will run one time. in the okay, after that here main, we are calling that init config in the function in the main. Then we have to write our code which we will run infinitely. So whatever steps are there, I will just copy and put them here first. Okay. First step is configure the port B as output. Control C. I'll just add them as a comment here. Okay. This is we have to do first. Configure port B as output. Then next, turn on the LED, turn off the LED with a delay. I'll copy this. Yeah, here these are the steps. I'm just copying them. We will do as per the steps. I'll add them as a comment. Yeah. This is what we are having the steps. I have commented them. So first thing is what? Configure a port B as output. So how to configure port B as output? How can we make port B as output? How to make port B as output, everyone? Yes, Shrikant, correct. Jaisurya, correct. Mitra, correct. Apart from these people, others, how to make port B as output? Raj Singh, Naga, Gauri, Nagasudha, Shweta, Jyoti. Everyone, how to configure port B as output? How to do it? How to configure port B as output? We have discussed how to make port B as output. Hello everyone. To make port B as output, what I should do with tris B? To make port B as output, what I should assign with tris B? Yeah, I have to assign tris B as what? 0x00. Tris B as 0x00 to make port B as output. Then turn on the LEDs. How to turn on the LEDs? What I have to assign it port B? Port B, I have to assign it as what? 0xFF. Then delay. So for delay, what I will do is I'll use a for loop. For loop, unsigned int weight. I am assigning weight with 50,000. Okay. Weight minus minus. So what will happen here? This loop will run for 50,000 times and this will act like a delay. This loop will run for till weight becomes 0. Okay, so this will act like a delay. Here I am writing a for loop which will run for 50,000 times. Okay, then later what? Turn off the LEDs. To turn off the LEDs, I can assign port B is equal to 0x00 to turn off the LEDs. Then delay. Yes, done till here. So turning on the LEDs, turning off the LEDs with the delay. This is we have written the code. Just save it. Control S, just save it. Okay. Done till here. Yeah, are you clear till here? Any questions till here? Any questions? Here 50,000 doesn't mean to any seconds. It's a random delay. Okay, someone is asking 50,000 means how much seconds? No particular time. It is a random delay. It's a random delay. Sarvesh and okay, Shrikant. We can use inbuilt function Shweta, but I am using here a for loop. This also will act like a delay. Fine. Now we have written the code, we have saved it. Next thing is what? We have to compile it. We have to what? Compile it. Okay, right click on the project, clean and build. Right click on the project, clean and build. So you can see here build is successful. Okay, you should get build successful. If there are any errors, you will get errors also. Here is the output window. In the output window, you should get build successful. It means your code is properly compiled. Your code is properly compiled. Okay, how to build? Just right click on this, clean and build. Right click on this, clean and build. Okay, once clean and build is done, okay, what we will do is we will open we have to upload the code. Okay, once its compilation is done, we have to execute the code on the simulator. Okay, open the simulator. Just click on it, it will open. Just click on it, it will open. Click on it, it will open. Okay, once you open your simulator, let me tell you here we have to choose the board. Okay, board, please choose it. Okay, pick Genius board. In the board option, go and select the pick Genius board. Go and select pick Genius board. Okay, then after selecting the board, select the controller PIC16F877A. PIC16F877A controller. Yeah, select the board, pick Genius. Select the board, pick Genius. Okay, select the microcontroller PIC16F877A. Then select the clock as 20 megahertz. Select the clock frequency as 20 megahertz. Then LCD as 16 cross 4. LCD as 16 cross 4 or 16, however, with anything is fine for now. Okay, once this is done, now this is our board. Okay, we have to load the code here. We have to load our code here, whichever code we have written. We have written the code for toggling the LED. Okay, that code we have to load here. So for that, go to File, load hex file. Go to options file, select load hex file. Okay, then go where into your folder wherever you have saved your project. I have saved it on desktop. You remember? I saved my project on the desktop. Okay, as Blink. As Blink. Okay, go to your folder wherever you have saved your project. I have saved it on desktop. I have saved it on desktop. So I'm going to desktop. There Blink. I'm selecting the project. Then dist. Default. Dist default. Production. Okay, then the hex file. Then the hex file. Okay, the next file. After that, what you have to do here is in the DIP switches. Here you can see there is a DIP switches. Here you can see DIP switches. In the DIP switches, we are having port D, port B. Port D, port B. There you select any of the LED. Here you select it as LED2. LED2 here is there, right? LED1, LED2. Pull that switch up. Okay, it is down here. Pull it up. Pull it up. LED2 here, there is a switch. Pull it up. Pull it up towards port B. Then RB0 is there, right? Pull it down. RB0 is there, right? Pull it down. Here we have one pin for RB0, pull it down. Here one pin for port B, pull it up. If you just click on it, it will pull up and pull down. Okay, this one you move it here, this one you move it here. RTC here pin is there, we have to move it towards RTC. This one towards port B to see the LED toggling. To see the LED toggling. Here switches you can see these are nothing but DIP switches. In order to use these pins, just make the setup. Otherwise, what is happening? Pin is getting connected to RTC. It's connecting to some. Okay, just make this setup to see the output. To see the output, just see the setup. Ma'am, if you assign port D as output, will the other set of LEDs toggle? No. We are using port B, so port B is working. If you use port D will work. In our code, we have used port B. Okay. So port B will work. If you want to use port D, you can do that one also. Do the setup. Just this DIP switches are there, right? DIP switches, you make sure they are connecting. You move this towards port B. This you move towards RTC. Clear? See, don't worry about this LEDs. We are not programmed it whether it's on or off. You don't worry about it. It's whether it's on or off. Some default state will be there. Don't worry about it. Only see port B. And in order to use port B, these switches are there to on and off this. The switches are there to use the LED or not use the LED. I want to use LED, then what I have to do, this switch is there, right? This switch I have to move it opposite side. If I don't you want to use LED, then I can move it towards LED side. The switches are there whether you want to use LED or not. Just to check whether you want to use LEDs or not. Okay. So just move it opposite side to use the LED. If you don't want to use the LED, move it this side. Is this clear? Clear everyone? Okay, so we'll stop here for today. Okay, who has got the output? Good and fine. Who has not got the output? Please, watch the recorded session. I'll upload it as soon as possible and do it. You have any questions, any queries? You can let me know through the discussion forum. Okay, please complete this. Okay, toggling LED. This is our first code. Okay, I'll stop here for today. Okay. One more time, let me brief out what we did for today. For today what we did was, we went and understand about port B. It's a 8-bit and bidirectional port, and TRISC-B is a data direction register for port B, which can be used to configure port B as output or input. Then what we got to know is, in the microcontroller to port B, 8 LEDs are connected. So in order to write a program to toggle the LED, what we have to do is first configure the port B as output. Turn on the LEDs, provide a delay, turn off the LEDs, provide a delay, and do it repeatedly. In order to do this, first we wrote the code in the MPLAB XID. We compiled it. After compiling it, we are loading the hex file into PiximLab, okay, to see the output. Okay, this is what we have done here. Okay, one more time, let me show you how to load the hex file here. To load the hex file, load hex file. Okay, then you have to go to the path. Where is your project? My project is in desktop. I'll go to desktop. In desktop, let me select my project. In the project, this default production, and you will go have the X file. Just load it. It will toggle the LED. Okay. Fine. This much what we have done for today. Okay. We are toggling the LED. This is our first code. So everyone, please do complete your installation. If you have issues with the installation, put it in a discussion forum. And please complete this first code. If you have any questions, any queries, you can let me know in the discussion forum and as well as tomorrow also. Fine? Okay. Thank you everyone. You can leave the session.